Another big data application in the area of traffic analysis. What you can see on the right side is a vehicle equipped with certain sensors to somehow measure the road conditions regarding maybe holes in the road, or as you might guess here, there's some connection to the sewage system or some water pipe system for firefighters. They can get water out of the street if there is a fire somewhere. And these data, these sensors on the truck, they can acquire a huge amount of data. These scanners, for example, scan the road every second 100 or 1,000 times, such that you can get, when driving over the street, you can get a very detailed profile of the street, a profile with all lids of the sewage system or whatever conditions you have on the road. Additionally to that, you have to also acquire the positioning data, which then help to tell where these road conditions occurred, such that you can after that model the roads in your county in precise detail. And as you might imagine, if you scan with 3D or 2D scanners the road 100 or 1,000 times in a second, then you get a huge amount of data from these sensors, and that's the point where you can identify it as a big data application. Then of course you have to store the data, in this case here first locally on the vehicle during the scans, during the operation of the vehicle, and after you arrive in the depot you might synchronize these data to a centralized database. After you synchronize to a database, or after you have it in the centralized database finally, you need to perform the data analysis part. Data analysis, again, like in the first traffic analysis application, regarding the geographical positions, you need to perform the geographical segmentation, and you need to assign the correct road segment so that you can tell exactly where are some holes in the road, for example, or where are certain lids of the sewage system. You have to identify outliers of the measurement systems. With these 2D or 3D scanners, it might be that you have certain physical situations where the sensors do not deliver the right data. You have to know these special conditions, and if you know these conditions, you can filter them out, and you will then in the further analysis not rely on these outliers. These outliers will lead you to analysis errors, and therefore you do not regard these in your data you want to do data analysis on. And finally, when you filter out the outliers, you have to detect damages, for example, damages in the road, holes in the road, for further managing the road maintenance and to determine which road damage should be done first, because it's a quite large damage, and the other damages should be maintained later on. Again, a visualization is important because you would maybe like to overlay the detected damages to a road. Again, you need the positioning data, you need the acquired data from the measurement vehicle, and this results in an overlay map which you can present to the specialist for the road maintenance. The application is no-brainer, and it's a management for your road maintenance, that you can in detail and quicker see what damages you have and what extent they have and how to prioritize these damage maintenance.